As another example, you want to work with the HTTPS in here. So first we open our Wireshark and listen to this NIC, and we start the capture, and here we try to connect to the twitter.com, which works with the HTTPS. If we hit enter, you see that it is secure, and you see that the response that we got from it. If we look at the Wireshark in here, you see all of these packets are using another protocol in here which is secure. If we look at the packet in here, you see different headers, so we don't see any plain text in here. Everything is encrypted, and we can make sense of the data. But what I'm going to show you in here are the other headers. So even though what we just asked is to browse a web page in here, but you see that there are different headers that have been added to our real information in here for us, for the packet to get to the destination. So every packet, it doesn't make any difference that what protocol you want to use, or every packet that you want to send to a server, it needs some information to get to the destination. So in here, if we look at different headers, the most exterior layer in here is the Ethernet header, which encapsulates the Internet Protocol version 4 header. It encapsulates the UDP, and all of that encapsulates the data. In this case, this is our data because we are using another protocol which is secure. So if we look at the most exterior layer in here, you see that we have 14 bytes. This is 6 bytes. If you look at the lowest tab, you see that 6 bytes are being with the color of blue. This is the destination MAC address. Then we have the source MAC address. So if you look at it in here, in the hexadecimal representation, 64, 70, and so on, this is actually the MAC address of my router, and this is the MAC address of my wireless NIC, which I'm currently using in my Windows. If you look at the command prompt again, and we type ipconfig/all in here, and we look at the MAC address of my wireless NIC, yes, with this IP address, you see that 0C8BFD and so on. Yes, 0C8BFD and so on. This is the exact MAC address of my NIC. If we also type ARP-A and look at the same interface again, you see that 192.168.1.1, which is my gateway address. Again, we could see it in here. The gateway address is 192.168.1.1, and if we look at the ARP table, you see that the MAC address resolved for this IP address, or the MAC address related to the router, is equal to 647002 and so on. You see this is exactly the same. So this packet is being sent to my router, which you could understand that because we are sending this packet to the device in the internet, the web server which is serving the twitter.com website. Because of that, we should send this packet to the router, and then the router would make a decision how to route this packet to this web server in here. So also we have a type in here which specifies that the next higher layer protocol is IPv4. So we close this layer and we go for the next layer, which is IPv4. So in the IPv4 we have at the minimum we have 20 bytes. We might have up to the 60 bytes of the required information. Some of the information that I need to specify is the header length, which is the length of the IPv4 header. It is 20 bytes. The total length, which is the length of the whole IP packet. So when we say the IP packet length, we mean the length of the IP header, the UDP header, and the data. So it is equal to 502. If you want to find the length of the whole packet, you would add the length of the Ethernet header, which is equal to 14 bytes. 14 plus 502 would be equal to 516, which you see in here. The length of the whole packet is equal to 516 bytes. So after that, we have some information. If the packet needs to be fragmented, then we should this packet should be reassembled at the other side. But we have the protocol which says the next higher layer protocol is UDP. Then we have the header checksum, which is for the security, a security check to make sure that the packet won't be manipulated throughout the process of the packet being traveled and reach the destination. We also have the most important section in the IP header are the source and destination IP address. It says that the source IP address is 192.168.1.44, which is the IP address of my wireless NIC. Again, if we look at the command prompt, you see in here that you could see it in the ARP table too. But if we look, the wireless NIC is using the IP of 192.168.1.44, and then we have destination IP address, which is equal to 192.99.116.129. Technically, this should be the IP address of twitter.com, but in our example, we are using a VPN or virtual private network, so we are sending our packets to this IP address, and the server at this IP address would route our packet to the twitter.com. So you might ask, what is the information in the of the twitter.com? How the server in the VPN, how does it know where to forward this packet? Well, all of this information are in the last layer in here, in the transport layer security in here, which we can make sense. But when it gets to the VPN server, all of this data would be extracted from this layer in here, and then it would be forwarded to the twitter.com. So what happens is that because the destination MAC address is my router, this packet would be sent to the router, and the router would look at the destination IP address in here and would make a decision to forward the packet to this destination in here, and at there it would just decode the information in the transport layer security and forward the packets to the twitter.com. Because I'm using a VPN, it's being more complicated, but actually it's not this complicated. So after the IP header, we get to the next next layer, which would be UDP or TCP. This is the transport layer. In this case, the information for the source port number and destination port number have been assigned. So in this case, the source port is this number, which says that when we want to connect to something, the operating system would specify a port number in the ephemeral port range to our program. In this case, this is the port number that have been assigned to us, and destination port number is 510 because the VPN that I'm using is listening at the port number of 510. But then when the packet wants to be sent to the twitter.com, because Twitter is working with HTTPS, which is listening at the port number 443, so this packet would be forwarded to that specific port number. So the destination port number for that direction, I guess, is 443. These information are all in this layer, which because they are being encrypted, we can't see them. So we have also other headers in here. Checksum for the security check, and the length, which is the length of the UDP packet. You might guess why it is different from the length in the IP. Well, because the length in here is the length of the UDP packet, which is actually the length of the UDP header, and the data in here is equal to 482. If we want to find the length of the whole packet, we would add the length of these two headers also. So the header of the IPv4 is 20. We could see it in here. It is 20 bytes. 20 plus 482 is 502. You see 502 is the length of the IP packet. 502 plus 14, which is the length of the Ethernet header, would be equal to 516, which is in here the length of the whole packet. So I just wanted to show you how different headers are being added to the main information and then being sent. Actually, it is a good thing that we are using the VPN, because now we see even the most complicated form. So if we want to do it ourselves, well, apparently we should take care of all of these things. In the later videos, we would see how we could take care of different headers using different methods that we would use to send information to the server and vice versa. See you in the next lecture.